Okay, let's do some examples of these properties. Okay, instead of using variables, we'll actually use some real numbers, values. Okay, so just to show, I'll start with the commutative property. Okay, if we have 2 plus 5, okay, well this is 7, right? That is the same as 5 plus 2, right? 5 plus 2 also gives you 7. So again, all we did was kind of switch the order of our two real numbers here. Okay, but it gives us the same value. Okay, if we look at multiplication, well, let's just use the same values. 2 times 5, that gives you 10. Okay, and 5 times 2, again, switching the order of my numbers, also gives me 10. Okay, so that's just a quick example of commutative property. Okay, now let's do the associative property. Let's do 3 plus 4 plus 5. And this time, for this one, I'm going to do 3 plus 4 first. Okay, well, 3 plus 4, again, I have to do this first. Because of my order of operations, I have to do what's in parentheses first. It's going to be 7. 7 plus 5 now gives me 12. Okay, let's switch the order up here. Let's do 3 plus, in parentheses, 4 plus 5. Again, notice values are the same. They're in the same order. Okay, but I put the parentheses in a different spot, which means I have to perform this addition operation before this one. Okay, so this will be 3 plus, okay, what's 4 plus 5? 9. Okay, we should all know that 3 plus 9 gives us 12. Okay, again, so we had the same answer, but we did, the order in which we added, we did in a different order. Again, if they're all addition, it doesn't matter. And we could do the exact same thing with multiplication. Okay, our identity, okay, these are pretty straightforward. Okay, if I have 2 plus 0, it's going to give me 2. Okay, another way I could ask this is if I have 7, 7 plus what number is going to give me 7? Well, that is 0. That's our additive identity. Okay. If I want to do the multiplication identity, okay, let's do 10. 10 times what number is going to give me 10? Okay, well, if we multiply 10 by 1, again, 1 is a multiplication identity. Okay, we'll get 10. And just so we're clear, I've been using nice real numbers. But, if we did something like 3/4 times 1, okay, this is still 3/4, right? Doesn't change. Okay, now one of the trickier ones, the inverse property, okay? Maybe not the addition part, but if I have 4 plus what number gives me the additive identity, which is 0, okay? It's going to be 4 plus its inverse, which is negative 4. It's 4's additive inverse is negative 4. Okay, if I have negative 3 plus what number gives you 0? Well, negative 3's additive inverse is technically, you can think about it as negative 3. The two negatives make a positive, right? This is technically negative 3. We don't want to write it like that. That's gross. Okay, this is just positive 3. Right? Basically, we're just flipping the sign. Okay, the additive inverse of 1/2 is negative 1/2. Basically, what number do we add to the given number to get 0? That is its inverse. Basically, you're just adding the same number with the sign changed. Okay. Now the multiplication inverse. Here is the multiplicative inverse. Okay. So it can be a little bit harder. Okay, if I have 4 times what number is going to give me 1? Okay. And you can think about this in a couple different ways. But it's going to be 1 over 4. And again, if you want to stop and think about it, you can think about 4 as just 4 over 1, right? 4 over 1 times 1 over 4. Okay, if we multiply across, you get 4 over 4, which is just 1. Okay. If I have 3 times what number is going to give me 1? Well, it's going to be 3 times its reciprocal, 1/3. Okay, I threw a new word there. It's reciprocal. Basically, we're flipping it. Okay, because remember, 3 is the same as 3 over 1. If I flip the numerator and the denominator, I'm multiplying it by its inverse. I get 1. Okay, if I start with a fraction, if I start with, let's do 5 halves, 5 over 2. Okay, what am I going to multiply by to get 1? Okay, well, I'm going to multiply by its multiplicative inverse. Okay, I'm going to flip it. And if I flip it again, if you think about it, if you multiply across, it'd be 10 over 10, right? Which is just 1. Okay, let's do a couple more multiplicative inverses. If I have 7/3, again, what am I multiplying by to get 1? Okay, I'm going to flip the numerator and denominator, which is going to be its reciprocal. It's going to be 3 over 7. And again, if we're not sure why that works, 7 over 3 times 3 over 7. Okay, remember we're multiplying fractions. We can just multiply straight across. We can multiply the numerator times the numerator. 7 times 3 is 21. Okay, multiply the denominators. 3 times 7 is also 21. 21 over 21 is the same as 1. Okay, that's kind of what's going on behind the scenes when multiplying by a number's inverse. All right. Lastly, we have the distributive property. Okay. Again, remember A, B, and C are real numbers. Okay. Let's go with 2 times 3 plus 4. Okay. And this is the same thing as 2 times 3 plus 2 times 4. I'll knock the chair over. Okay. Well, 2 times 3 is 6. 2 times 4 is 8. 6 plus 8 is 14. Now you might be thinking, well, Mr. Rieger, why didn't we just follow order of operations and do 3 plus 4 first? Okay, well, let's see what happens if we do 2 times 3 plus 4. Again, the exact same problem. But this time, instead of distributing, I'm going to just do the order of operations. Okay, 3 plus 4 is 7. 2 times 7 is 14. Now, you are right. Okay, this was a lot quicker. Okay, but this idea of the distributive property, okay, we're going to be using a lot more with variables. Okay, it's not gonna be, you're not going to be able to just add what's inside together so nicely like this usually. Okay, we're going to have to actually distribute. Okay, and later on in lessons, you're going to see me showing the distributing like this. Okay, I distribute the 2 to the 3, distribute the 2 to the 4. Okay. And just kind of give you an idea, this is more so kind of what I'm talking about. All right, we can't actually combine this x and y together. We can't do x plus y to get xy or anything like that. Okay, if we distribute this 2 to the x, we have 2x plus 2 times y, 2y. Okay, this is really where the distributive property becomes useful. And we'll use that later on as the year goes on.